Okay, in this lesson we're going to cover some two-dimensional geometry information. Two-dimensional geometry is often referred to as plane geometry because it's in a single plane. I'm going to start out just kind of covering some basic definitions just to make sure we're all on the same track. I'm going to start out with the definition for an angle. An angle is formed by two rays. You may have remember that definition. A ray is a point that starts and it has a starting point and then it goes off in one direction. So these would be two rays that have a common vertex. The point where they meet is called the vertex. So this right here is your vertex. This would be a ray here and a ray here. Okay. An angle that measures 90 degrees is often called a right angle. This would be an example of a right angle. It has that little box in there to kind of show you that it's a 90-degree angle. An acute angle is an angle that measures between 0 and 90 degrees. So this measure up here would be an example of an acute angle because the measure between here and here, that is less than 90 degrees. This would be a right angle here. It has that box in there to indicate that it's 90 degrees. Or a right angle. The next one would be an obtuse angle. Measures between 90 and 180 degrees. I don't know what applications you're going to have in the future in terms of memorizing these terms, but I think most of us are aware of a right angle being perpendicular or right 90 degrees with a little box like that. But acute, you can kind of remember that like a cute little baby, it's between 0 and 90. It's going to be the smaller of the two. And obtuse is an awful lot like the word obese. It's really large. It's between 90 and 180. This would be an example of an obtuse angle. It's greater than 90 but less than 180. I also feel like I need to talk about the concept of a straight angle. From any point on a straight line there will be 180 degrees, and very often that's called a straight angle, or referred to as a straight angle, but there's 180 degrees equal to a straight angle. So I need to include that as well. Okay, now we're going to go ahead and we're going to be talking about different pairs of angles. A pair of complementary angles are two angles whose sum is equal to 90 degrees. So they add up to 90. That's what that word sum means. Two angles whose sum equals 180 degrees are called supplementary. Okay, and then we've got two drawings here that are going to help us kind of keep this straight, or at least help us to put a picture to it. Here we've got an example of two lines that intersect, and from this straight angle information that I gave you here, 180 degrees along a straight angle, if I cover this up, we can see that there's going to be 180 degrees along that line, 180 degrees along that line, and on either side of the line. So if we know that there's 180 degrees along this line and we've got 137 in this angle here, we can use that information to take this number away from 180 to find that that missing angle would be equal to 43 degrees. So this would be 43 degrees over here. Also, we'd know that this would be equal to 43 degrees because when I cover this up here, there's 180 degrees along this line as well. And if there's 137 degrees here, there must be 43 degrees here. Same thing here, that if I know there's 180 degrees along a line, we have 43 degrees here. We know that we're going to have 137 degrees here. So we can figure out all of the missing angles just by the fact that we know along any line, any point along a line, there's a total of 180 degrees. That we get that fact from supplementary angles. Each of these pairs along either side of any line are supplementary pairs of angles. Okay. On our next picture, we've got this right angle in here that tells us these two angles are going to sum together to be equal to 90 degrees. And again, that was our definition for complementary. So this is an example of complementary angles. And just very similar to what we did over here, we're going to take the 90 degrees. We know that the total degrees is 90 degrees, and we're going to take 39 away from it to find that this is 51 degrees here. Okay, so that's getting our bearings straight with angles. Okay, moving on to some other scenarios. I'm going to talk about, I've got a definition here. a ray that divides an angle into two equal angles is called an angle bisector. Okay. What we're going to do here is just a little bit of an experiment or challenge here. We're going to draw an obtuse angle. Remember what obtuse means. And we're going to label it MNP. And then we're going to assume another angle, MNP, or that MNP is a total of 142 degrees, and it's going to be bisected by another ray, NQ. And we're going to calculate all of our angles here. So we have to kind of speculate, and I'm not going to be super exact about this. Just want you to picture what it might look like. I'm going to draw a picture here, and I'm going to assume that this is about 142 degrees. So we're assuming that we got a total of 142 degrees. I'm going to put little dots on here, points on my picture here. This is going to be M, N, P. Now notice N was the center between these three. These three letters will help you name your angle. The middle one is always the vertex. You're also going to see this kind of notation, angle M, N, P. That little notation there is communicating, it's a shortcut for communicating angle. Okay, so we've got MNP, we know that's 142 degrees total, and we're going to have this ray NQ. So NQ is going to have to be somewhere shooting out this way, NQ, and we're assuming that it broke each of these into two congruent angles. So congruent means that they're equal to each other, so we're going to make this little dash mark. That dash mark is a way that you communicate that two segments, or two angles in this case, are equal to each other. And so the fact that this bisects, we have the word bisect, tells us it breaks it into two equal parts. So we'd take 142, divide by 2, we'd find that each of these angles would be equal to 71 degrees. So we had a description here, and we pictured what it might look like and did some calculating. So we ended up with angles MNQ and QNP, and we calculate that they both are equal to 71 degrees. So something very similar to that is we are going to look at, well, I have to introduce the whole concept of a segment. A segment is a portion of a line, and it's identified by two endpoints. Again, with the notation piece of this, sometimes you might see AB like that with a little line above it. That's meaning segment. If you see something like AB with two arrows like that, this is communicating the full line that AB would sit on as well, or the segment AB would sit on that line AB. Okay, just a little bit of notation stuff there in case you run across it. A segment bisector divides the segment into two equal segments. So very much like the angle bisector broke into two equal angles, segment bisector breaks into two equal segments. So in this little experiment, we are going to draw segment XY so that it bisects segment MN. Okay, now remember, MN is the one that's going to be bisected. So what I'm going to do is I'm going to draw MN here, and I'm going to speculate about where I think the midpoint would be, because obviously if it's bisecting, it's going to have to intersect at the midpoint, and that is going to be our letter B, or point B, that point of, and it's going to break that into two equal parts. Again, I can use those dashes to communicate that. But XY is the segment that is going to bisect this, and XY is not bisected, it's MN that's bisected. So again, we were taking a description and calculating and anticipating what a picture that would match that could look like. Okay, so now we've got a challenge. We're going to draw segment PQ, very much like what we did up here, drawing segment PQ, so that it is a perpendicular bisector to segment JK. So it's not just a segment bisector, it is a perpendicular bisector. So I'm kind of challenging you to speculate what you think perpendicular might be. You've probably heard of the word before. It means that it's two lines or two segments or something that are at 90 degrees to each other. In other words, they form a right angle. Okay. notation that we often see for that is an upside down T that communicates perpendicular. So we have to kind of picture, what might this look like? Segment PQ, so that it is the perpendicular bisector. Now remember, PQ is not being bisected, it is bisecting JK. So I'm going to draw JK here first. I know that it's being bisected at Z, so very much like what I did up here. I can break these into two congruent parts. I'm going to put 2 dashes on here. That's another way, as long as I have matching tick marks. And it's perpendicular. This time it has to be perpendicular. Doesn't mean that PQ is bisected, but it is. This is going to be Q. This is going to be P. It is at right angles. So the way that this picture differs from this one is that PQ is at right angles to JK. So I was kind of going about it a little bit backward rather than showing you the picture and then analyzing all the things that we can assume about it or learn from it. We tried to picture what it possibly could look like. I'm hoping we can get through some of this next one. Now we're going to take a look at just lines intersecting on a plane. Okay, 2 lines that cross each other at a single point are said to intersect. When 2 lines intersect, 4 angles are formed. The angles opposite each other are called vertical angles. We had a picture of this before when I showed you supplementary angles, and they are going to have equal measures. And just remember that we have 180 degrees on either side, so just like what we did on our earlier slide here, we know that we have 147 degrees along a line. We know that, or 180 degrees along a line. If we know that that's 147, we know that this would be 33. We saw this pattern where opposite angles are going to be equal to each other. We may have noticed that last time. There's a name for that is called vertical angles, and so we don't really need to do all the subtracting from 180. Once we've done 147 from 180 the first time, we can kind of speculate the rest of this by virtue of the definition of vertical angles. Same thing here. If I know that that's 88 degrees, I can hop across here and know that that's 88 degrees. One way or the other, eventually I'm going to have to back it up and take 188, or I'm take 88 from 180, and then find that we have 92 degrees here and here. So again, these 2 angles are vertical angles, these 2 angles are vertical angles, just like we had back here. Okay, 2 lines that never intersect are said to be parallel. And the symbol that we use for that all the time is just 2 L's side by side, I guess you could look at it, but 2 upright letter L, or 2 upright lines communicating parallel. The printed lines in your notebook paper are example of parallel lines. 2 lines that intersect at right angles are called perpendicular. We kind of speculated that before on our exploration earlier. The edges of your paper are at perpendicular corners, at the corners. A transversal. Now this is a little tricky. I feel like there's some information that I may have left off here. Transversal is a line that crosses a pair of lines. It doesn't necessarily have to be parallel lines, but we're going to speculate and just speak about the situation when a transversal crosses parallel lines. Okay, so that's kind of misleading to think that it always has to be parallel lines. It can be any pair of lines, but we're going to really nail down parallel lines. Okay, when a transversal crosses parallel lines, there's a total of 8 angles formed. That's it. We have 2 parallel lines. There's going to be a lot of relationships here that we're going to take a look at. But first of all, we want to look at this picture here. We've got 1, 2, 3, 4. I've kind of changed up the order here. But we're going to list the pairs of vertical angles and that are therefore equal, opposite each other. So we have 1 and 4. We have 2 and 3. We have, in this lower intersection, we have 5 and 7. And we have 6 and 8. Okay, now we're going to start into just really zeroing in on some other pairs, not just vertical angles, but some other pairs of angles that pop up. We have corresponding angles. And corresponding angles are pairs of angles that are in a similar location but different intersections. So I used to always teach this according to a map, but students today are just so into their GPS systems they don't read maps very easily. So we're going to look at this and identify upper, lower, right, and left, and so forth. So I guess we can ignore my little directions here. So we're going to look at corresponding, meaning they have the same location but different intersections. So when I look at this, 1 and 5 are both at these two different intersections. They are both at the upper angle. So I know that I've got 1 and 5. Now I'm not going to draw too much more in here because it gets really doctored up once we get rolling here. So I have the upper angles. If I look at each intersection separately and look at the left angles, I have 2 and 6 that are going to be corresponding. Our lower angles, we have 4 and 7. And then the right angles, we have 3 and 8. These are all corresponding angles. The deal is that they are going to be equal as long as this transversal is crossing two parallel lines. Something else that I really should throw in here is let's label this line A and this line B, and I can use this notation. A is parallel to B, and let's say that this is our transversal T. You'll notice that on a lot of drawings your lines might be labeled a lowercase letter, as I've done here, and a lot of times you might have this little drawing off to the side or this little notation off to the side to specify that you have parallel lines. Okay, continuing on, we're going to have a pair of alternate interior angles are on opposite sides of the transversal, and they are equal to each other. So in other words, if 1 and 5 are equal to each other, and we have 4 and 7 are equal to each other because they're corresponding, notice that 4 and 5 are also going to be equal to each other, and they are called a pair of alternate interior angles because they are on alternate sides of the transversal, but they are in the interior space of the two parallel lines. We also have two pairs of alternate exterior angles that are on alternate sides of the transversal, but they are in the exterior space. So if I cover up the interior, you can see that 2 and 8 are on alternate sides of the transversal, and they're in the exterior space of the parallel lines. So we've got 2 and 8. We also have 3 and 7. I'm sorry, we have 1 and 7. They are on alternate sides of the transversal and in the exterior space here. So 1 is on the outside, 7 is on the outside, so we have 1 and 7. I just did that backwards. I realize I forgot to have you name. I forgot to write down when I was talking about my interior angles. I was saying 3, 4, and 5 are alternate interior, and 3 and 6. I said it, but I didn't write it. Okay, basically in a nutshell, as long as you have one of your angles, you saw from up here that as long as you have one of your angles, you can find the rest of the angles in the intersection. And when you know you have a transversal crossing two parallel lines, you know because of corresponding angles, you can kind of get started and find all the rest of the angles in that other intersection. So even though you have 8 angles here, as long as you're given just one of them, you can figure out the other 7.